Hello, everyone. Happy Wednesday. We made it. I'll give you all some time to get settled, and then we'll get started when the bell rings. All right, today's due now. 2 questions for you. The first question I want you to answer in the chat. So what's your current flavor? I can't speak today. What's your favorite flavor of ice cream? That's your first question. The second question are, what are the requirements to use difference of squares? Why would I use difference of squares to factor? That second question we're going to answer out loud. So keep your answers to yourselves.
Cookies and cream.
Type that in the chat. Type that in the chat. Got raspberry, vanilla, strawberry. Cookies and cream, cookie dough. I love that too. Cookies and cream. For those of you that just joined, your due now is on the screen. What is your favorite flavor of ice cream? Put that in the chat. And the question that I'll ask out loud today is, what are the requirements to use difference of squares to factor? What do you need? In what situation would you use difference of squares to factor? Cookie dough, cool. All right, take 30 more seconds to get your answers in the chat if you haven't already, and then I'll call on someone to answer number 2. Oreo, awesome. All right. Okay, what are the requirements to use difference of squares to factor? What do you think, Q?
Like, you probably use it when they got nothing in common.
Say that again, sorry.
I say you probably use them when they got nothing in common.
Sorry, Liana. Hang on one second. I'm gonna mute you for a sec. I called on Q and then I'll call on you next. Q, go ahead.
What's it called? What's the requirements? It's just like using that magic X thing.
What'd you say, sorry?
Using the magic X, I guess, to solve it.
Magic X is for 3 terms, so it's a trinomial. So how many terms are in difference of squares?
2.
2. So that's the first requirement. You have to have only 2 terms.
They got square rooted.
You got to have perfect squares. That's the second. And then there's one more. What sign has to be in the middle of the 2 terms? A plus or a minus?
Minus.
Minus. So those are the 3 things. You have to have 2 terms. You have to have perfect squares, so you should be able to take the square root of both terms, and you need to have a minus. Liana, were you going to add anything to that?
No.
Cool. Thanks for participating, though. All right. Good. Let's go ahead and do our good things for today then. Today's good things will come from Hannah, Liana, and Sandra. Hannah, what's your good thing?
I would say my good thing is that I woke up.
Cool. Awesome. We're glad to see you. Thanks for sharing. All right. Liana, you're up. What's your good thing?
That after this, I get to catch up on some of my Netflix shows.
Oh, yeah. What are you watching today?
I'm watching something called Imposters.
Okay.
So that's what I'm be watching.
Cool. Do you recommend it?
Yeah, maybe.
Maybe. All right. Thanks for sharing. And then Sandra, what's your good thing?
My good thing is that I went to school to pick up some books.
Awesome. Cool. Thanks for sharing. My good thing was it was really nice outside yesterday, so I got to go play tennis with a friend, which was really fun. All right. Next, I'm going to give you guys a few minutes to ask any questions about the homework that's due tonight. So remember, you have that Canvas assignment with the factoring worksheet, and it's going to be due tonight at 11:59 p.m. So does anyone have any questions that you want me to answer?
Oh.
Branson and
Yeah.
Hannah.
How do you submit it?
So did you find the submit button?
Yeah.
Okay.
But
So,
like, what'd you say?
I was gonna say you're gonna have to upload a picture. So let me show you how to do that. So if you go to your Canvas, and then you go to Algebra 2 Loop, lesson. Where are we? Okay, factoring review. Click the link at the top. You got this far, right, Branson?
Yeah.
This would help if I was on student view, so let me try it over again. All right, so here it says submit assignment. At the bottom, you want to hit choose file, and you're going to upload whatever picture that you took of your completed assignment. And then and then it will upload right here. It will say your file right here when you finish uploading it, and then hit submit assignment.
So how do you do it? Like I clicked the
I just want to.
I clicked the thing and like I couldn't like type nothing.
Dang, you can type.
It's not gonna type it. It just should open up a new. Were you able to see the worksheet?
Yeah.
Okay, so once you can either print it out and then take a picture and then upload the picture, or you can just do it on a blank piece of paper, but there's no space for you to type in your answers. You're gonna have to do it out on paper and then upload the picture.
I drew
Okay.
right on it.
Karen, what'd you say?
I said I drew right on it. Like, you know how the Chromebooks come with a little pencil?
Oh, okay. Then so you just like saved it and then uploaded it?
I saved it and then I just pressed a little editing tool and I haven't turned it in yet, but I was planning to like take a picture or yeah, save it to like one of my Google Docs and send it.
That's perfect.
Oh, I'm sorry.
And then Hannah, what was your question? You didn't have a question?
I have a question. No question.
No question. All right. Anyone else have a question about yesterday's homework? No? Okay. Let's go ahead and get started with today's notes then. So you should have been able to find today's notes on Canvas. Make sure you print them out if you have a printer. If not, you can take them by hand. That's fine too. Let's go ahead and share my screen. All right, can everyone see that? Quick thumbs up if you can see my notes. Cool. All right, today we're going to be talking about different types of variation. So variation, what is variation? Variation is a special relationship between variables, and those variables we're going to be talking about are our favorites, x and y. So it's a special relationship between x and y. There's two different types of variation we're going to be talking about. The first is inverse variation. So that's in the format y is equal to a over x. And the way we say that is y is inversely proportional to x. So in other words, if x is getting bigger and bigger and bigger, y is getting smaller and smaller and smaller. They're opposites because you'll notice that x is in the denominator. So if it gets bigger, if you're dividing by a bigger number, your answer is actually going to be smaller. Like 8 divided by 2 is 4, but 8 divided by 8 is 1. So the bigger your denominator is, the smaller your answer is. So that's inverse variation. So that means that y is inversely proportional to x. That's the first formula you're responsible for knowing. The second formula is direct variation, and that's in the format y is equal to a times x. So the difference between inverse and direct, in inverse, x is in the denominator. In direct, x is multiplied with a, so they're both together. There's no denominator. And the way we say this is y is directly proportional to x. So these are just specific relationships between variables. So basically this is saying that if x goes up, y goes up. So if x becomes bigger, y becomes bigger. If x becomes smaller, y becomes smaller. So they're going in the same direction, whereas inverse is going in opposite directions. And a, we refer to a as our constant of variation. Constant means just a number. So a has to be a number, and it's called your constant of variation. Any questions about the definitions? All right, example 1, tell whether x and y show direct variation, inverse variation, or neither. So your first step is you want to make sure that you get y isolated. So you want y all by itself on one side of the equation. So right now you have xy equals 5. I'm going to go ahead and call on someone to answer this next question. Xy equals 5. How do I get y by itself? How do I get y by itself in this equation? What do I need to do? What do you think, Nancy?
How do I get y by itself?
Yeah, so how do I get that x that's next to the y?
Move it to the other side.
I want to move it to the other side. How am I going to move it to the other side? Am I going to add it? Am I going to subtract it? Am I going to multiply it? Am I going to divide it?
You're gonna divide it?
Because it's x times y. So to get rid of it, you need to do the inverse, which is divide. So that will cancel out the x's on the left side. So you've got y is equal to 5 over x. And now that you have y by itself, you're going to see which one of these formulas does it resemble. So does everyone see how x is in the denominator?
Mm-hmm.
So if x is in the denominator, it's going to be inverse variation. Anytime your x is in the denominator, it's inverse variation. And you'll notice that your a value in this case is 5. A is always just going to be a number. In this case, it's 5. All right, questions on A? All right, let's look at part B. Y is equal to x minus 4. First step, make sure y is by itself. It is. It's all by itself on one side of the equation. And then it's equal to x minus 4. Now we have to see, does this formula resemble inverse or direct? Or if it doesn't resemble either of those, it's going to be neither. So I'm going to go ahead and call on someone. What type of variation do you think y equals x minus 4 is? What kind of variation do you think it is? Let's go to Venus.
What your question was?
Do you think this equation looks like inverse, direct, or neither?
It looked like direct. Is it direct?
I could see why you'd say direct, but do you see how direct they're multiplied together?
Oh, so neither.
It's going to be neither because you can't have a minus sign in between. It has to be multiplication for it to be direct. So it's neither. Good. All right, next question, part C, y over 2 is equal to x. So first step, you want to make sure y is by itself. Right now you have that 2 in the denominator, so you need to make sure you get rid of it. How do you get rid of the 2? How do you get y by itself? How do you get rid of the 2? What do you think, Josh?
I wasn't here yesterday,
Okay,
so I don't know stuff.
we all are starting on the same page today. So how do I get rid of 2?
I don't know.
All right, so it's y divided by 2. What's the inverse or the opposite of division?
Multiplication?
What'd you say? Sorry, one more time.
Multiplication?
So you need to multiply both sides by 2. So divided by 2, multiplied by 2, those will cancel out. So you're just left with y is equal to x times 2, which is 2x. Normally when we have a constant multiplied by a variable, we put the constant first and then the variable. So y is equal to 2x. Any questions on part C?
So this one will be direct.
Who said that, Liana? Yep, you are.
Yeah.
Yes, so we still have to figure out, oh, I don't know why I boxed that. I didn't mean to do that. We have to figure out if it's inverse, direct, or neither. And in this case, it is going to be direct because the constant 2 multiplied with our variable x. So it's direct. Any questions about part C? All right, let's go ahead and flip the page and do example 2. So example 2 is dealing with tables of values. So these ones are a little bit different. We're going to be working backwards to check if it's inverse or direct. So before in example 1, they gave us the equation and we were able to see if it was inverse or direct. This time we're going to get a table and we have to work backwards. So to check if it's inverse variation, what you want to do is you want to multiply the x's and y's together. And if it gives you a constant, another word for constant is the same number. So if it keeps giving you the same number, then that's going to be inverse variation. For direct variation, you're going to divide y divided by x. And if that keeps giving you the same number, in other words, if it's constant, it's going to be direct. I always remember direct divide for these tables. All right, let's look at part A. So here's your table of values. Your x's are listed on the top, your y's are listed on the bottom. To check if it's inverse variation, you want to multiply the x and y together. And then you're going to write your answer in this part of this table right here. So I'm going to start with these two pairs right here. So 2 times negative 12, which is negative 24, and I'm going to write it in that first box. Then I'm going to go over to the next pair. So 4 times negative 6. 4 times negative 6 is negative 4, or negative 24, excuse me. Now you're going to go to the next group. So 6 times negative 4 is also negative 24. Promising.
Do we have to write these?
What'd you say, Liana?
That wasn't me.
Oh.
I said, do we have to write this down?
Yes, you do.
Okay.
And then lastly, 8 times negative 3 is negative 24. Okay, so remember for inverse variation, the products, so when you multiply, they have to be constant. In other words, they all have to be. So let's check. We've got negative 24, negative 24, negative 24, negative 24. Those are all the same number, so it's constant. If it's constant, when you multiply them, it's going to be inverse. Just for funsies, let's check direct. Let's make sure that direct is not constant. So to check if it's direct, you're going to divide y divided by x. So you're going to do negative 12 divided by 2. You always want y in the numerator. So negative 12 divided by 2. That's equal to negative 6. Make sure you reduce it. Then you want to do negative 6 divided by 4. Make sure you reduce it. So find out what goes into 6 and into 4. Those can both be reduced by 2. So that's negative 3 divided by 2. Already, you know these are not going to be constant because these are not the same number. But let's go ahead and fill it out still. Let's do negative 4 divided by 6. That can also be reduced by 2 because 2 goes into both of those numbers. So it's negative 2 divided by 3. And then the last one, y divided by x, negative 3 divided by 8 is negative 3 over 8. So you can't reduce that any further. So you'll notice these are not constant because they're not the same number, which is what we figured anyways because we already knew it was inverse. So technically we didn't really have to check if it was direct since we already know that it's inverse. But it doesn't hurt to check. Any questions on that? All right, let's look at part B. We've got our table up here and our inverse and direct tables below. All right, so for inverse, we have to multiply our x and y together and make sure that it's constant. So let's go ahead and do 1 times 2, which is 2. 2 times 4, which is 8. I already know that this is not going to be constant because I don't have the same number. If things are constant, we're going to just check and see if they're the same number when you multiplied. They're not, so it's not constant. So we know that it can't be inverse because it's not constant when you multiply. Now let's check direct. So for direct, we want to divide y divided by x. So you've got negative 12 divided by 2. Make sure you reduce it. So negative 12 divided by 2 is negative 6. Oh, you guys, I'm sorry. I was looking at the wrong table. Please excuse me. Cross that out. We're looking at this table over here. We have to do 2 divided by 1. My bad, which is 2. Sorry about that. I had a momentary brain fart. All right, now we're going to do 4 divided by 2, which is also equal to 2. So this looks promising. We've got 2 of the same number, but we need to make sure all of them are the same number. Then we're going to do 8 divided by 3, rats. Can't reduce that any further. That one's not matching up with the others, so that's unfortunate. But just for fun, let's do 16 divided by 4, which is 4. All right, I'm going to go ahead and call on someone for this question. When we did y divided by x, is it constant or is it not constant? What do you think? Sandra.
It's not constant.
Not constant. So follow-up question, Sandra, is it going to be direct variation?
Yeah.
No, because for it to be direct, it would have to be constant, but we know it's not constant. So if it's not inverse, if it's not direct, it's going to be, so at least one of them has to be constant. So for it to be inverse or direct. Does that make sense? Any questions about how we tell the difference between inverse and direct with a table of values? Okay, last one, example 3. The variables x and y vary inversely and y equals 4 when x equals 3. Write an equation that relates x and y, then find y when x equals -2. Wow, it's a lot of information. Key thing I want you to see is that it says vary inversely. When it says vary inversely, and that's a clue that you are going to be using this formula right here, the inverse variation formula. Y equals a over x. So go ahead and write down y equals a over x on your paper. First step, you want to figure out what the a value is. So you want to write an equation, but to write an equation, you need to know what that a value is. So what we're going to do to find the a value is we're going to use our information right here. We know that y equals 4 and x equals 3. So you're going to plug that into your equation. So you're going to plug in 4 for y, and you're going to plug in 3 for x. All right. Remember, your goal is to solve for a, so you have to solve for a. How can I solve for a, Karen?
You're going to you're gonna multiply 3.
Yep, multiply 3 on both sides. So 3 times 4 is 12. On the right side, the 3's will cancel out, and you're left with a by itself. So you've got 12 is equal to a. So now you're ready to put it into the equation. So whenever you write the equation, you leave x and y as is. Don't plug in anything for that. But you're going to plug in a 12 in for the a. So that's the equation. Any questions about how we got the equation? All right, lastly, it asks you to find y when x equals -2. So in order to do that, you're just going to replace the x with -2. So y is equal to 12 divided by -2, which is -6. So y is equal to -6. Any questions about example 3? Does anyone need more time to copy this down? Okay, I'm going to go ahead and stop sharing this, and we're all going to go ahead and access the Big Ideas math assignment together because I want to make sure that you all know how to log in. So I'm gonna give you the link in just a second for Big
I
Ideas.
got a question.
Yeah, what's up?
Are you gonna are you putting these Zoom thingies, these Zoom calls on Canvas?
Yes. So they should all be up right now. There should be links to the YouTubes.
Okay.
It's under current lessons.
Okay. Thank you.
Good question. All right, everyone, here's the link. Go ahead and click the link, and then you're going to log in using the login that we created on Monday. Is anyone having trouble logging in? When you log in, you should see a screen that looks like this. Anyone having trouble? All right, once you have logged in, you're gonna click the tab that says assignments at the top. And you should see your first assignment for Big Ideas Math, it's 7.1. Does anyone not see an assignment? Okie dokie then. So to start your assignment, yours is gonna say start. I already started this assignment, so mine says resume. So we're gonna click that. Resume. All right, so yours is gonna start at number 3. Ay, 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 why is it going so slow? Mamma mia. Okay, I've angered it apparently. It's not happy with me. It's fine. We'll get through it. All right. All right, let's go ahead and answer number 3 together. This will be a freebie for your homework today. So the first question says, tell whether X and Y show direct variation, inverse variation, or neither. So I'll give everyone a minute to think about it. I want you to type in your answer on your own Big Ideas Math. That way you get one problem done for today, and then I'll call on someone. So decide whether this is direct, inverse, or neither. And then I'll call on someone. All right, Ethan, what type of variation is this, do you think?
Direct.
Direct? Okay, let's see if you're right. So let's go with direct. And then at the bottom right here, it says check answer. So that's wrong. And the reason why it's wrong is because for direct variation, your constant and your x need to be multiplied together. And right now they're divided. So let's try it again. What type of variation do you think this is, Hannah?
I think it's neither.
All right, let's try neither. So let's check our answer. So that's wrong too. So this is actually inverse variation because do y'all see how the x is in the denominator? Anytime the x is in the denominator, it's inverse variation. So let's check our answer. Ding, 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 we got a green. So now you know you got the right answer and you can move on, all right? It's really important that you check your work because during virtual learning, I'm going to be grading your homework based on accuracy, not just that you completed it. So don't just write random answers and go to the end and submit it because if you didn't get any of the questions right, then you're gonna get a 0, So even if you did some work. So make sure that you use that check answer button because it will give you feedback as you go. So you shouldn't have a surprise at the end on what your score was, okay? The next thing is that when you're ready to submit, there won't be a button on the screen that says submit. You have to go up to your name. So click the name and then click the drop down menu and you have to hit submit. And then it's gonna ask you, are you sure you wanna submit? If you're good, hit submit. If not, then say cancel. If you wanna take a break, then you can just hit save so your answers will save and then you can come back to it at a later time. Any questions about how to use Big Ideas Math? Anyone struggling to access it? Remember, this is how you get your grade for this class. So if you can't access it, let me know now. We can help you figure that out. Okay, all right, that will bring us to the end of our class today. Here's your homework for tonight. You want to make sure you print out your notes for Thursday. Those will be up by tonight. And then your factoring assignment is due on Canvas. Make sure to upload a photo of your completed worksheet by tonight at 11:59 p.m. And then your Big Ideas Math assignment is due Thursday at 11:59 p.m. So that's tomorrow at 11:59. Alrighty, y'all. We finished early today, so you are welcome to log off if you are good to go. If you have any questions, I'll stick around until 2:40 to answer those. So, or if you want to work on your work and have me answer any questions, you can do that too.
Okay, bye.
Bye, see ya.
Miss B.
Yeah, what's up?
Oh, I'm sorry. I had to take an important phone call. What were we supposed to do again?
You want to log into Big Ideas Math and make sure that you can see your assignment for tonight.
7.1.
Do you remember log into Big Ideas Math?
Yeah, I know how to I know how to log into it.
Okay, so yeah, it should be up there and it's due tomorrow at 11:59. And then don't forget your Canvas assignment is due today.
Alrighty. And what about yesterday? Because I was having internet problems and couldn't make it to class.
So go ahead on Canvas and click current lesson and it will have the video from yesterday with the notes and then the assignment for you.
Alrighty. Thank you, Miss B.
You're welcome. Let me know if you have any questions.
Bye.
Bye, see ya.
Miss Bawa.
Yeah, what's up?